Yeah, no, don't worry. Okay. Right. Yeah, my favorite is at the top.
All right, happy Tuesday. How's everyone doing? You have a nice weekend? Yeah, me too. This is what I was doing. Going on long walks with a cute little child. So we have a good one today. We're starting with data visualization. We started, working with data sets last class. So we downloaded a data set, we opened it in Excel. We did a few things, some very basic operations. And then we we got sort of familiar with Python. A lot of you, I think, I was hearing after class, still have a lot of work to do to feel comfortable in Python. And that is A-okay. We are like week 2 of the semester. It's very appropriate to feel like you aren't fully comfortable with Python. So if you're in that category, feel comfortable there. That's just where we are at the moment. We're going to do a little bit of work in both Excel and Python today. I'm going to show you how to do the same things in both pieces of software. The way we as people who work with data think about Python, we think of it as essentially doing the same kinds of operations as what we do in Excel. It's just we do it with code instead of with a spreadsheet. So that's where we're going today. Before we get in, are there any questions? You all have a nice weekend? Okay, love to hear it. Hopefully you didn't do a lot of work for me over the weekend. Hopefully you're able to get all your work done during the week. And you can go enjoy the nice weather. It won't last forever, but it's here right now, so enjoy it. Okay, unfortunately, I'm gonna have to close this picture. So we left off talking a bit about the survey results. We didn't have a lot of time to get into all of it, so I just wanted to show you a few things about who's in the room. I find this pretty interesting to do at the beginning of a semester. And I'm going to demonstrate some data visualization best practices. I'm gonna show you some of these as we go through. We've already seen some of this, so I'm gonna go pretty quickly. So this is just a visualization of like where everyone's coming from. One way of doing this would be to collect information about like the state or country of your hometown. But I chose to do this in a slightly different way, to measure where you're coming from based on how many miles away your hometown is. And so the picture looks like this. We did something like this in notebooks last time, but this is just a nicer figure showing how far away your hometown is. So if you're more than like 2,500 miles away, you must be coming from international, unless you're like in Hawaii or Alaska, I guess. So we have a few international students. We have a big clustering of distances much closer to 0. So one thing I would want to do is zoom in and try to figure out generally the distances from this clumping of data. So that's what I did. I zoomed in just to distances that are under 1,000 to get a better picture of this subset of the students in this class. And you can see a lot of people are coming from Pittsburgh directly, so this is like the Pittsburgh metro region. And anyone know like where 300 miles away might land us? Yeah. Where? New York. Yeah, so New York is roughly 300 miles away. What's maybe another major city? Philly, yeah. Which I think a almost everyone, or a lot of people in this group are coming from Philly. I think New York might be a little bit further than 3, might be like 400. Okay, yeah, so more eastern. What's your name? Tony. And what's your name? Are you from Philly?
Yeah,
Nice. Yeah, how many of you are from Philly? Or like Philly area? Nice. Okay. So I have family in the Philly area, in Philly, Fishtown, and in the suburbs of Philly, like Quakertown, Doylestown area. So nice. So this is like eastern Pennsylvania or New York, kind of that area. Maybe New Jersey too. Nice. And then we looked at when people are born. So this is a different way of measuring age, just like when your birthday is. And I zoomed in on this main clustering of ages. There's someone born in the 90s. It was me. But yeah, most people in the class are born in this range. So you can see the most common birth year is 2005, but 2004 and 2006 are also common. We sort of already looked at that last class. We also looked at majors, but this is just a nice visualization of this. This shows two things. One, most people in the class are majoring in econ, and two, I can't predict all of the majors on the list. A lot of people are in other. As I said, deep apologies for this. I should have collected which major you actually are, and just had you report that. So this is interesting. Second, finance is the second most common primary major, and then a lot of computer science. So we've already seen a lot of this. And I just wanted to show you a couple of things about the stats and the relationship to what we're doing in this class. This is the histogram of whether you liked your stats class. You'll remember I was at the very bottom here. It's nice to see that a lot of people liked your stats class, which is great. We're going to be doing a lot of statistics stuff a bit later. One question you might ask of this data, as we talked a little bit about, is whether you liked whether there was a relationship between whether you liked your statistics class and whether you're excited about this class. I plotted this data set, the scatter plot, in some detail last time, but I think this is a better figure. So on the horizontal axis, I have how much you liked your statistics class. This is what's called a joint plot, which we'll talk about a little bit later. It's kind of fancy, so I don't want to make things too fancy right off the bat. But I have a histogram of whether you liked your stats class on the top here. And then on the vertical axis, I have how excited are you for this class. And it turns out, thankfully, a lot of people are somewhat excited. I collected this before we did Python last class, so maybe this has gone down a little bit. But on the vertical axis, we have your excitement for this class, and then I have a histogram of that excitement on the vertical axis. And going in, like when I collected this data, I would suspect that there's a positive relationship between these two variables. And generally, that's what we see. If you liked your statistics class, which is maybe the closest previous class to what we're doing in this class, you would come in with maybe a little bit more excitement for what we're doing in this class. And the data is noisy, and as you'll see as we go through the semester, often what we do, the data sets we work with, the data can be pretty noisy. So there isn't a very clear trend. But you can see that there's potentially a positive relationship. A lot of the density in the scatter plot happens right around here, although there are outliers on both sides, or data that sort of is distributed around the central trend. But it looks like generally, if you liked your stats class, you're more excited for this class, although the pattern isn't quite that clear. Okay, and then another thing we might ask is your confidence in Excel related to your excitement for this class. And when I collected the survey, I asked you, I told you that we would be using Excel before I collected the survey. So you knew that there was Excel in this class before I asked you about your excitement. What I'm doing here is actually splitting up the data into two groups. One is people who feel confident in Excel, and that's the box plot on top. And then I've listed everyone who's not confident in Excel in this second box plot, so in the one on the bottom. And I've also included this the second kind of visualization on top, which is just plotting the actual data points. So these are, each one of these dots represents a student in the class. And what you can see is, generally, if you're more confident in Excel, you're more excited for this class, which, as we go through the class, I hope to convince you, if you came in without Excel, you should still feel very excited about this class. So as you go on, you'll learn that you can do everything. But just coming in, it looks like people who have some experience are more excited for the class, which is interesting. And then the last thing I wanted to show you is whether confidence in Python is related to your excitement for this class. So just like we did with Excel, we're going to look at the relationship between Python confidence and excitement for this class. And what you can see is the histogram at the top here is just the distribution of your excitement, your confidence in Python. And as I showed you earlier, most people in this class, understandably, are not that confident in Python. For a lot of you, this is your first time working in code. If you have no prior experience working in code, this class is the place to be. You should feel very confident that if you have zero confidence in Python, that you're in the right place. So many people are not that confident in Python, and you can see the distribution in that group of excitement for this class. And I think the trend here is a little less clear, but it looks like there might be a positive relationship between confidence in Python and excitement for the class. But a few people, it looks like there might be a upside down U relationship. But this scatter plot isn't that conclusive. So there's not a strong relationship between excitement for the class and Python experience, which is potentially understandable. You don't have to come in with prior experience to feel comfortable in this class. So maybe there's a lot of excitement in just learning Python, which is, I would feel the same way. Okay, so these are just some general findings. I wanted to present this to you at the beginning. I think this is pretty interesting. This is, at least for me as someone who works with data, this is an interesting way of understanding trends in a population. And this is not something we could have figured out if I had just asked you these questions on day one. We needed something systematic. We needed a systematic way of understanding the population, and that's something we can do with data. And when we have the correct visualization, it makes it much easier for us to understand relationships in our data. So what we're doing today is starting at the ground floor. We're going to start working on creating good visualizations using best practices for doing visual summaries. So I'm going to ask you a set of questions over the next couple of slides, and you're going to tell me some answers. Ignore the takeaways. We're going to start working with categorical variables, and then we're going to get into an exercise and actually do some of this in Excel and Python. But the thing I want you to be focusing on as we go through these slides is which figure is easier to understand. We want to think, one of the key ideas with data summarization is when you create a figure, you want that figure to communicate as simply and as easily to your audience the point you're trying to convey. And the best visualization tool isn't all the same across every type of variable. This is one of the big points. Each variable type has its own best visualization tool. I'm going to show you sort of a summary of which ones are which a little bit later, but I want you to be thinking about which visualization tool is better, which one is easier for you to read as an audience member or as a participant in this class. Okay, so I have a data set, and you can go to the website and we'll work with this data set a little bit later. So if you want to just take a look at it, you can. So you can download the coffee shops data set here if you like, but you can also just follow along as we go. But this is just a visualization I made from that data set. And what I want you to be thinking about is which of the figures that I'm presenting is the best and easiest visualization to understand the question at hand. So for this slide, the question is, which state has the most locations? So I'm going to give you like 10 seconds. Just look at this, pick the one that seems like it's easier to understand, and then I'm going to ask you which one you prefer in a second. Okay, so we have two options. We have the bar plot, and we have the pie chart. If you're trying to figure out which state has the most locations, how many of you prefer the bar chart? And how many of you prefer the pie? Okay, interesting. So I want one representative from both categories to make your best case. Someone from the bar chart. Why do you prefer the bar for this question? Yeah.
Because it's a number, like not a percent.
Okay, nice. So a bar kind of represents more of like counts, where a pie chart sort of represents maybe more percentages. Yeah, remind me of your name. Chase. Yeah. So that's a great summary of why people like bar charts better. Yeah.
Well, I was gonna say the pie chart's probably bad because pie chart represents like 100%.
Okay.
And if you're viewing by states, those aren't every state in America, so it's a little deceiving.
Sure. Yeah, remind me of your name.
Matt.
So Matt is pointing out potentially we have coffee shops that are not in this data set in the country. Like definitely there are coffee shops in Pennsylvania. I went to one this morning, and they're not in the data set. We have a lot of ideas about potentially pie charts representing the percentage of a whole, and so maybe they're not appropriate for this context. Yeah.
I maybe would have chosen the bar graph if it was ordered better. So
Oh, sure.
kind of like seeing it from increasing to decreasing or decreasing to increasing.
Yeah.
Probably would have made it more visually appealing to me.
Yeah.
But the pie chart, just seeing, I don't know, just seeing it kind of next to each other like that is easier for me to kind of see that California has like the biggest, like the most like coffee shop locations. But,
Yeah. So remind me of your name. Ruby. And it's Matt and Chase. So Ruby's pointing out potentially one thing we could do to improve the bar chart is actually order the categories based on their counts, which is something we're going to do in the slides in a second. Yeah, so that's great. So Ruby's maybe saying like just intuitively the pie chart may be a better tool. Yeah.
Yeah, I think it's easier to just look to the pie chart and see that California is the biggest chunk. And I would say the biggest difference is being able to see that California has a count of 6 much faster with a pie chart than a bar graph.
Yeah.
Because you have to first identify, okay, which one's the longest, you see that's California. And then you have to look at the x-axis to see, okay, that's 6.
Totally.
So it's all in one in the pie chart. I don't see anything necessarily wrong with bar graph. I think either could work.
Yeah.
But I feel like if you're trying to convey the information as fast as possible and make it easy for any audience, I would say the pie chart.
Yeah, that's great. Remind me of your name?
Luke.
So Luke is saying, maybe agreeing, let's see, Ruby. So Luke is agreeing with Ruby generally that in this case, the pie chart may be quicker to view and just see sizes relative. But also, Luke is pointing out the pie chart has numbers just built into the areas. So like the number is listed on top of the pie slice, where to figure out the actual number with this bar chart, at least the way it's set up, is you have to find which one is the largest and then sort of run a line down to the horizontal axis to find the number. And just like Ruby, we're actually going to do this in the slides. We're actually going to improve the bar chart to make it better in that way. But the default in general, and you'll see this in a lot of bar charts, is to not do that, to not include the number on the bar. But the good ones do, and I'll show you those, an example of that in a second. But the nice thing with pie charts is they sort of come built in with the numbers labeled on top. I think I agree with the majority of the class that for me, the bar chart is easier to read. If you're trying to find the largest, all you have to do is look which bar is furthest out on the horizontal. Here, it may be just with visual instincts, it may look like Texas and California are pretty similar, where it's really clear from the bar chart that Texas and California are not similar. California has 50% more, where it's not quite clear from the bar chart that that's true, unless you read the number. Okay, so with this example, it's a little maybe murky. You could go either way. If you're just trying to find the largest, I would say both can potentially work in this case. What about this example? Does Florida or Washington have more shops? I'll give you 10 seconds to pick which one you like better. Okay, 10 seconds. I want this to be brief. I want you to, when you see a figure, I want you to think instantly which one do you like better. Does it communicate what you're trying to do? If it's not quick, if it takes a while to read, there are probably ways to improve your figure. Okay, so how many of you prefer the bar chart for this question? And how many of you prefer the pie chart? Okay, even stronger consensus, although maybe not full consensus. So someone tell me why this case is, the bar chart is really useful here. Yeah?
I mean, the actual number doesn't matter. You just ask which one has more. It's very good. Easy to see. Florida bar is higher than Washington, so.
Yeah, so all we have to do is identify the two categories, and then we can compare their height on the horizontal axis. And you can see Florida definitely has more than Washington. And what's your name?
Alexis.
Alexis, yeah, thank you. Someone else from the bar category want to represent, yeah. Yeah, it's so hard to read the pie chart for this question. You have to like do some like unit circle, like angle comparisons, right? Pretty tough. You can look at the numbers, so Washington and Florida, but if you're just seeing the sizes, which is the main reason we want to use figures, is for visual sizes, essentially. That's pretty tough to see. At least for me. Anyone want to represent pie charts? Yeah.
When I look at these, I just look right at the numbers. So as soon as I see like 3 and 2, I just like know right away rather than looking like, oh, it's like 1 and 3, even though it's like probably pretty clear on the bar chart. But for me, I just go straight to the numbers.
Yeah, great. What's your name?
Alex.
Alex. And Alexa?
Alexis.
Alexis. So yeah, Alex is saying, look, the numbers are really valuable. When we put the numbers on the visual component in the figure, It just makes it much easier to read. And for Alex, that part is what sort of crowds out the rest of what's going on in the figure. Just the number is really nice. Okay, so generally for me, I think I agree with the majority here. We don't have to follow consensus in this room, but for me, the bar chart is just especially good in this case. And I would say best practice, really no one uses pie charts. I'm going to show you one example of when a pie chart could be, I would say, equally good as a bar chart, but you'll basically never see pie charts in scientific work. We just basically never use them. And to such an extent that the main visualization package that we will use in this class actually doesn't even have one built in because we just don't use them. I'll show you one example of when we do use them in a second. Okay, so how about a third question? If you're trying to figure out how many shops are in Florida, which one is easier? 10 seconds. Okay, hands for bar chart, hands for pie chart. Okay, someone tell me why. Yeah.
With the pie chart, you just look at it and you don't have to interpret anything. With the bar chart, you have to look at it and figure out which what's between to look for.
Nice. So the bar chart, you have to look at which bar and then run a line to the horizontal axis and then figure out what that number is. Where in the pie chart, all we have to do is find the slice and then see the number. What's your name?
Yeah.
Hannah and Sophia. I don't think I asked you for your name, so Hannah and Sophia. Hannah is saying including the number on the visual component actually is very helpful for us when we're trying to figure out the answer to this question particularly. So you'll see the question we ask impacts which visualization and which visualization we would choose, and it also the visualization, the way we construct it is useful for answering different kinds of questions. So these are things we need to be thinking about. Going back to Alexis. Going back to Ruby's earlier comment, what if we add numbers to the bar? Or was that your comment, Luke? I can't remember.
I don't know. I just don't want to take credit from someone else.
I'll give credit to both of you.
Yeah, that works.
So one thing we might do is just essentially copy the idea in a pie chart, at least the original pie chart, and we're just going to put the numbers on the bars themselves. I find this much more useful than having a horizontal axis that we have to read. I'm just doing the visual work for you, which is that's the main idea of a visualization. I want to do the work for you. I want to tell my audience in as simple a way as possible what is contained in the data. And as an audience member, this is nice for you, right? Like, you love this. It's much easier to understand what's in the data set in this way. A visual is intended to save the audience work. Okay. So how many shops are in Florida? How many of you prefer the bar chart in this case? And how many of you still prefer the pie chart? Okay, maybe mixed. Maybe they're equal here. I would say potentially they're equal. I'm going to show you another trick that we can do. Now that I have included the numbers on the bars, that horizontal axis actually means nothing anymore. It doesn't add anything extra to the figure. I don't have to use it to interpret the size of the bars. So what I did is I actually got rid of the horizontal axis for the bar chart. So now I have each of the categories listed. I have the sizes, so you can easily see the sizes. And then if you actually care about the number, I have the number for you there too. This is how I like to make figures. to remove as much clutter as possible. Some people may think this is going too far. We, as reasonable people, can debate these things. Your preferences will go into how you construct your figures. If you really despise removing horizontal axis like this, I'm sorry, you're in for a long semester. I do this maybe more than I should. But in this case especially, I think the horizontal axis actually doesn't add that much. We don't need it for really anything. The sizes are represented as they are. Okay, any questions here? So I think the best visualization of this categorical data set is this one. We have the numbers represented on the bars. We have, or we're pretty close. There's one more thing I want to show you. We have colors for each one of the categories, which gives us sort of some visual separation between them. And I've removed as much clutter as possible, including the pesky pie chart. Let's see. It was either Ruby or Luke recommended doing one extra thing. Actually, I think this was Ruby, was ordering them. So states have no inherent order. Pennsylvania is definitely at the top, but everyone else is equally valued. How many of you are not from Pennsylvania? Okay. I'm sorry. I love your state too. But one thing we might do is just order by count. So there's no inherent order with nominal categorical variables like this. But we may want to just order by size. So the last thing we could do is just order these nominal categorical variables by size. And I think this is like the end game of good categorical, nominal categorical variable visualizations. Looks kind of like this. Any quibbles, questions, concerns of quackery? Okay. You think you want to make some nice visuals? Well, here's one last thing, I guess. The one case where it's potentially okay to use a pie chart is with binary categorical variables. So one question we could ask is, how does California compare to the whole? So what's the percentage of coffee shops that are in California? So if we're thinking about percentages, like Chase and Matt brought up earlier, we may not want to use a bar chart like this. So instead, what we could do is just have two categories, right? Instead of listing all the states, we could have California versus everyone else. This is a binary categorical variable. It could look like this. So we have two categories now. You're either a coffee shop that's in California, or you're a coffee shop that's not in California. The bar chart looks fine. We have two categories. And the pie chart also looks fine. How many of you, for this question, would prefer the pie chart? And how many would prefer the bar? Okay. So this is potentially one case where I think a pie chart could work. Best practice is still to use a bar chart, but if you used a pie chart here, that's sort of fine. I will tell you, using pie charts in like good academic research is generally frowned upon. Like, I would recommend you not do it. But here, I would say these communicate equally well the two sizes. And then the last thing is percentages. I would say potentially here, the pie chart is actually a slightly better tool, although I would still default away from them. partly for like cultural reasons. We as like an academic culture generally just stay away from them. But in terms of like the principles we're developing in this class, I would say a pie chart may be actually better in this case. Okay, so the main takeaways here, binary categorical variables, you could use a pie chart or a bar graph. For nominal categorical variables, like we've talked about in this little example, use a bar chart, bar graph, and then order the bars by size. And then if you can add the number on top, that's even better. And then with ordinal categorical variables, we haven't really walked through a big example of ordinal categorical variables, but we're going to do it in exactly the same way. We have a bar graph, and we just order the bars based on their inherent order and not based on their size. Okay, and then general best practices for visualizations. You want to remove clutter, so take out as much as you can to communicate your main idea, and keep it as simple as possible. And then put the visual information, put the information near the visual component. Okay, so we're going to do this together. So you all have your computers. What we're going to do is navigate to the course website, and we're going to download this data set, coffeeshops.csv. So we'll run over here. I have this exercise recorded in Excel. This is from last year. And you can take a look at that if you like. I will be posting, I said I'd post these right after class, and for a technical reason that hasn't happened yet, but those will, last lecture and last exercise will get posted here. So for exercise 1.1, you can just click on the Coffee Shops dataset, and it should download for you. So I have a downloads folder, and I have my CSV file. And as you remember, CSV stands for comma separated values. And what we can see in the data set, this is a very simple data set. What we can see is the list of coffee shops by state. So we have a bunch of coffee shops, and we just have the states listed out. Before we start working with this data set in Excel, I just want to talk a bit about data organization, or like file management. This is not a class about Python. This is not a class about Excel, although we are using both of those tools. This is also not a class about file organization. It's like, I already see the yawns. But as we're going through this semester, we're going to be encountering lots of data sets, and it's important to keep these things organized. If we don't, things become very complicated very quickly. You may not believe me right now, but as we go through this semester, it will be increasingly important to organize our files. So what I've done here on my desktop, I have a couple of folders. This is some data for later in the semester. I have this folder for this class. So all the in-class stuff we do will happen here. And then I have part 1.1 as a separate subfolder. So what you can do is just create a folder either in your desktop or in your documents folder, wherever you like on your computer. And then you can keep the files, the data set, in a subfolder. So what I'm going to do is actually just take this coffee shop data set and drag it over. Actually, that's not where we want it. Let's put it back. Today we're in part 1.1. So part 1.1. So I'm just going to have a separate folder for today. I'm going to take this coffee shop folder, coffee shop data, and just drag it over. Okay, and then I'm not going to need the downloads folder for a second. So now we have the coffee shop's data set in the correct folder, just to keep us organized as we sort of progress through the semester. So I'm just going to open this, double click on it. It opens in Excel. And then we're going to take a look at what's actually contained in this data set. Okay, so we can just go row by row. This is just a list of all the different states, or all the different coffee shops, and which state they're in. So what we want is to visualize this data set. We want a visual that describes the number of coffee shops by state. And we can do this both with a pie chart and with a bar chart. But the place to start here is with a summary table. So what I'm going to do is I'm going to create a summary table. So what we want are just the counts of each one of the coffee shops by state. Before we start on this, is everyone set up in Excel? Anyone still having issues with Excel directly? Okay, let's maybe chat after class if you have a second, and we can get you set up. Anyone else? Okay. So with these in-class exercises, you're going to be doing work on your computer, but I also want you to be checking with people around you. You're going to run into technical issues, and as we go through the semester, the people around you will be very helpful for resolving your technical issues. So someone else next to you has probably figured it out, if you haven't, and vice versa. So if you figured it out and someone around you hasn't, then offer some help. What we're going to start with before we do the visualization is just creating a summary table. So we just want to find the counts for each one of these states. How many coffee shops are in each one of the states? If I just select this data and I go to Insert and I click on, let's do a bar chart. I can click on this thing and it'll give me a column chart, and I just plot this out. This is not great. This is not a very useful figure. What we need in Excel is actually a list of counts. So we need to create like a summary table of all the different counts. This is not a bar chart, unfortunately. This is much easier in Python, but what we need in Excel is to actually create a table. So what I'm going to do is I'm just going to list out all the unique values among the states. So which states are represented? So let's create a new column. We're going to call this states. And then you'll remember we have our unique operator, our unique function. And what I'm going to do is just select all of the coffee shops. So that's A2 through 18. And I'm just going to hit enter. And that's going to give me the entire list of all the unique states. Okay, any questions here? It's very similar to what we did last time. The next thing we want to do is count up how many coffee shops are in each one of these states. Does anyone know a function that can work with this? Excel has a function called COUNTIF. So I just want to walk you through. We're not going to be able to cover each one of the functions in Excel in this class. This is not an Excel class. But one of the useful functions in Excel is called COUNTIF. So I'm just going to list out all the counts. And I'm going to hit equals and then COUNTIF. And you can see what it's asking for. First, it has a range, and then it has a criteria. So I'm going to select the entire data set, so all of the different states. So this is going to ask Excel to count how many times our criteria shows up in this list. So here's the list. I'm going to put the comma to tell it the list is over. And then I'm going to enter one of the states. So I'm going to say Texas. So what this function is doing is looking for Texas, counting how many times Texas shows up in our list. And if I hit enter, then it will count. And you can see, just quickly verifying, Texas shows up 4 times. Okay, so we're going to take about a minute here. I want you to, or 30 seconds, I want you to count up the number of times Washington shows up in our list. Take about 30 seconds, and then maybe check your number with someone next to you. Yeah.
Oh, yeah. So close the blinks after Texas.
Okay, what number do you have? A 2? Anyone else get 2? Nice. So someone describe what you did here. May sound simple, but there are a couple of ways of doing this. Yeah.
So when we did the count, and we basically asked Excel to count the number of categories that we're going to provide. So
Yeah.
we selected the cell so that we gave it a specific data to count from.
Yeah.
And then we specified what we want to count with each function.
Nice. So, and what's your name?
Savi.
Sabi. So Sabi's saying, we just basically did the same thing as we did here. We're just using COUNTIF. We select the list, and then we enter the condition. So what we could do is just write it out a second time. So we could say equals count if, and then give the range, and then give the criteria. But anyone do it differently? Yeah.
I referenced the cell with the Steve
Nice. And remind me of your name?
Lucas.
Lucas. And we have Luke and Lucas. So what Lucas is saying is instead of entering Texas manually, Lucas entered the cell of that's in our unique list. So I'm going to, Lucas's approach actually has some advantages, and I want to show you some of those advantages. So instead of listing Texas, writing that in manually, I'm going to just select the Texas cell. So I'm going to select this and hit enter. So this gives me the same count because it's saying look at the entire list and then check from that list whether this unique value is in the list. So we don't have to write out Texas to get the unique counts. So the next thing we could do is just select this. We're referencing the same list for Washington, but all we're doing is referencing Washington instead of Texas. So I'm just going to copy this cell with the function in it. So if I hit Command-C on my Mac or Control-C on a Windows computer, I can then paste that function into the next row below. So I'm going to do this, and then we're going to talk about what that looks like. So I'm going to paste it here, and I get 2, just like you got 2. Okay, someone tell me, is this correct? Yeah. Technically, no. And why is it not correct?
Because it counts from A3 to A19, not A2 to A18.
And what's your name?
James.
So what James is saying is, even though this gives us the correct number, copying and pasting actually has a bit of a nuance in Excel. which we can see by double clicking on this. When we copied and pasted, it moved everything down. So it's correctly looking at Washington because we've copied from the cell above and we've copied one below. So it's moved the references down by one row. But in the process, it's also moved the reference for the list down by one. So this list is now down one row from where it was earlier. So everything has been moved down. And this is giving us the right answer, but it's not giving us the right condition. So it's technically not correct. Does anyone know what the fix is for this? How do we get around this problem? Yeah.
Put dollar signs in front of the row.
Yeah, in front of the row. So Excel has this nice little feature built in where we can actually lock the reference as we move as we like copy and paste. So if I put a dollar sign in front of the number in the cell reference, I'm not going to put a dollar sign in front of the C because I do want that to move, but I don't want the row numbers for the range list to move. So I'm going to run this, and then I'm going to copy and paste here. And then let's check whether this worked. So when I copied from here to the Washington row, the reference for Washington has now moved correctly. So now we're checking the count of Washington. How many times does Washington show up in our list? But because I've added these dollar symbols to the range numbers, so for the rows, then this list has stayed in place. We've locked the cell numbers as we've copied down. So this is now technically correct. And it's giving us the right number. Any questions here? Okay, so let's finish this table. Someone tell me the last three. We're going to take about 30 seconds here and finish writing out this table. If you're familiar with Excel, this may be a lot of review, and that's okay. If you're not familiar with Excel, this may feel like a lot of upfront work, and that is also okay. We're going to take about 30 seconds. Let's get some numbers. Matt.
Florida is 3.
Oh, hold on just a second. We'll take about 30 seconds. All right, Matt had some answers.
Florida 3.
So Florida's 3. So what I'm going to do to get this is I'm going to copy this with Control-C and then paste it here. And I get Florida has 3. I'm just going to double check that it's doing the right things. Okay?
6.
6 for California. 6 for California. Check it's doing the right things. And then someone else. What's Florida? Yes.
2 for New York.
I'm sorry, New York. Yeah. Remind me of your name. Sophia. That's right. And Hannah. So I'm going to again just paste in. Nope, that's not right. Copy and paste. So check it's doing the right things, and I get a number 2. So nice. Anyone get different numbers? Okay, so we've created a summary table. These are the counts. We're going to do the same thing in Python, but with one line. But this is a valid approach in Excel. So you can create the counts. We just go through and we count up all the different states. Okay, so the next thing we want to do is create a visualization. right? That's the main thing we're trying to do here. We've created a summary table, but let's create a visualization. So what I'm going to do is go up to the top bar here, click Insert, and then I'm going to click on Bar. So you can look at all these different visualization tools, or column, I guess is what Excel calls it. So I click on this, and then there are a bunch of different options. Horizontal is nice, vertical is nice. For now, we'll just use the vertical. This is what's called a clustered column chart, which will work for our purposes. But before we get there, I just want to actually select the data, select our summary table, click on the visual tool, and have it spit that out for us. And this creates a pretty good visualization. So once we've done the summary table work, Excel will do a lot of the work for us. One thing we could do is change the title. So I could just double click on counts and relabel this as coffee shops by state, which would be a little bit more informative than just state or count. And then we have the list here. And there's more we could do. One thing you might want to do is, I personally generally prefer horizontal bar charts. Your preferences may be different, but I think this is maybe a little bit easier to read, especially when we get very large numbers of categories. It's easier to have the text for the description of the bar to be horizontal. But you may like the original one better, and that's fine. Any questions about this? We can also create a pie chart. So we could insert, if you go up here to pie, Excel does have this built in. So feel free to use it. But like I said, in general, pie charts are deeply frowned upon. In fact, most people teaching this class would say never use them, which I think is maybe a little bit too strong, but that's the general guidance. When I took over this class, the slides said, do not use pie charts. I'm giving you a little bit more nuance to have in your toolbar. Okay, so here's a pie chart. This includes colors. It does not include numbers on top. A lot of issues with this figure. There are lots of ways to format figures in Excel. I don't create my figures in Excel. There's a lot of formatting. It can be kind of complicated to make them. So I'm going to show you a much better approach in Python. Okay, any questions here? So the steps. We took this, we made a summary figure, or summary table, using the list of coffee shops by state. We created counts, and then from the counts, we then created a pie chart and a bar chart. We're going to do a very similar thing in Python, except it's going to be much simpler. We're not going to have to do all these different functions. I'm going to get rid of this pie chart. They're pesky, and we should delete them. I'm going to save this. When I hit save, it saves as saves to the local file. But what you'll notice is this is the local file here is not. It's still a CSV file, which doesn't actually generally save the figures. To save the figure in the file, we have to hit Save As. So you'll see this banner across the top, which says, if you exit, you may lose some data. Excel has a very particular data file, data format. If we hit Save As, it'll save it as an Excel workbook. So it'll have the ending to the file name .xlsx, which just tells you that it's an Excel file. So we can save all of our work to the Excel file. And then I'm going to exit out of this. Actually, I'll leave this up. But on the course website, we can click on Notebook, and this will open for us. The notebook. I haven't actually opened the notebook, the movie, in a while. That joke will get old, which hopefully you'll laugh at the oldness of the joke, because it's not a very good one. Okay, so here's the standard view of a notebook, right? We have the opening cell, we have the description for the notebook itself, which I've preloaded for you. I have some of the imports, and I have a file path to where on my website you can find the data set. So if you run this, it'll run all the imports. So we just hit play, and that runs the cell without running the rest of the file. So just doing that one particular step. And then the first thing we want to do is just load the shops data set. So I'm going to run this, and that loads the shops data set. And I don't need to run the text cells because they're not actually executing code. So each time, just as a refresher, each time we run one of these cells, we're actually asking Python to execute it. So it's taking that action. It's just like a list of steps in Excel if you were to write them down. We're just writing down the list of steps that we're taking one by one. And generally, the way we proceed is just as you read text. So it's you start at the top, and then you go line by line as we go down. So the next thing I want to do is just look at this data set. I just want to verify that it looks the same as what I'd expect. So I'm just going to do shops.head, and that'll give you the top 5. Or if you want to see the whole data set, you can just print out the whole data set. And this is exactly as we'd expect. So we have all the different rows, each one of the states. This is a bit cumbersome, so I'm not going to leave it printed. But you'll remember one of the things we can do is we can create a summary table very easily using shops.valueCounts. So if you have the slides, you can just copy this. I'll post the copyable, the interactive slides on the website if you want to follow along with that. But for now, you can just copy the shops.valueCounts. And I'm going to post that directly into the cell. So shops.valueCounts, and that creates the summary table. So in Excel, this took us a couple minutes. In Python, this is simple. So we're just creating a table of value counts. Okay, so nice. So we have our summary table. And then what we want to do is create a bar chart that does the same thing. So we want a bar chart with all of the counts. So what I'm going to do is go back to this exercise, the dataset 1, and I'm just going to use what we call a count plot. So this is from Seaborn. So SNS, you'll remember, is our nickname for the Seaborn package. And we're just asking Seaborn to go into all of its functions, look at the count plots, which just goes through and counts up each of the unique categories, and then creates a bar plot based on the counts. So we don't have to create a count plot or a summary count if we don't want to. We can just have Seaborn run count plot. We give it the data set. We say data will be coming from shops, which is the data set we just loaded. And then we're going to have the y variable, so the vertical axis is just going to be the list of all the states. And then hue is just for color. I'm going to delete that for now if we want. And run this. Okay. How many of you were successfully able to create a count plot in Python? Okay. So let's take a second here. If you haven't successfully completed it, maybe chat with someone next to you. I want to see a figure that looks like this in your notebook. We'll take a second here. If you've already completed it, give someone around you a hand. Just help someone out next to you. And if you have no one near you that hasn't made a figure like this, maybe tell someone next to you the most fun thing you did this weekend. It'll take about 30 seconds here.
Yeah.
Okay. So the most fun thing I did this weekend, if you count Monday as the weekend, I'm training for this race called Hyrox. Anyone knows, heard of it? So like my gym just did a whole, like a bit of a simulation of part of that race on Monday, which is fun. The weather was nice. It was a good time. Okay, so if you're still struggling to get this set up, feel free to keep working. Just because I'm talking or we're moving on to a new idea doesn't mean you shouldn't be continuing to work on these things. You're more than free to keep working. One thing I might do, Seaborn has another little bit, another part of the function which allows us to add colors to our bars. So what I'm going to do is actually go in and define hue. So this just allows us to add some colors. And I'm just going to say I want the colors to be based on the state. So this looks a little bit redundant, but I'm just telling Seaborn to make each state a different color. So I'm going to say state, and then I'm going to close the parentheses and run this. And this gives us different colors by state. Any questions here? Nice. So we've created a nice visualization without creating a summary table. And the reason we can do this is because we're using CountPlot. It just does the summary table for us behind the scenes, and we can do it in one line in Python, which I think is amazing. It's very powerful. Okay, so this is the bar chart. For the slides, I basically did something very similar to this, except I added some other nuances, which you can play around with if you like. One thing you can do with AI is you could say, make this pretty. So this is this hash just means that it's not Python code. So it's written in the Python cell, but it's not actually doing anything in Python. This is what we call a comment. And what AI will do is take your comment and turn it into some code. So if I hit enter and create a new line, well, sometimes it works. this is one of the problems of doing these things live. So if it doesn't work in line, you can go over to Gemini on the side and add it here. We could say make it pretty. We'll see what happens. All right. So, but that's how it would work if it were connected properly. So here it's saying to add a title, an X label, a Y label. It's taking off the legend, and if you want this this edit to your cell, you can hit accept. And you can see it's added some stuff, but it hasn't really made it great. So one of the principles of using AI is it will not write things perfectly for you. You have to understand how these tools work to be able to get good results using AI, at least at the moment. So I'm actually going to undo this because I like the simpler one better. Okay, but you should add more to this. All right, this is a great place to start. This is the visualization, some of the visualization tools that we use for categorical variables. We're going to do one more exercise, one more data set, and then I'm going to send you out the door. The next one is, so I have some code here for pie charts if you wish to use them, but like I said, I don't recommend it. In fact, Seaborn doesn't even have a pie chart that you can run. You have to use a different visualization tool. I've included the code, but you do not have to replicate this. What we're going to do next is look at this dataset employment status. We have about 5 minutes. So what I want to do in the first minute or so is just for you to take a look at the dataset directly. So load the dataset and play around with it, and then tell your neighbor generally what you think is included in this dataset. So if you run this, it'll load as status. I want you to look at the dataset, look at the raw data, and tell your neighbor what's included. And then I'll ask you in a second. What is this dataset describing? Okay, what are we seeing? Someone describe this to me. So what I'm going to do first is just print out the data set. So AI is thinking I want to value counts, but I don't. So I'm just going to run this. So someone describe this for me. What do we see? Yeah.
It's just taking some people saying they're employed.
Remind me of your name?
Matan.
Matan. So Matan is saying, we're just listing out a bunch of households. We have a bunch of unique IDs by household. And then we have a second column, which is telling us whether someone in the household is employed. This data set should look a little familiar from one of our exercises last time. Okay, so if we were trying to create a visual to describe this data set, where might we start? Let's take about a minute here. Tell someone next to you what we might do. If you have the slides, you may have seen where we're going. This is one of those things, like, we see a data set. The step going from the data set to choosing the correct or the most useful visualization is a step in itself that I will ask you to do. So what might we do next? Maybe chat with your neighbor, come back together.
Don't worry, I've never used them in papers.
Yeah, that's the correct answer.
Yeah.
Yeah, I think
Okay. What do we do next? What type of variable is this? Yes. Binary categorical. Yeah. Your name?
Ava.
Ava. So Ava is saying binary categorical variable. We have a categorical variable which takes two possibilities. And what do we generally recommend for a visualization of this type of data? This type of variable? Yes. Remind me of your name? James. Pi or bar graph. And for me, I'm always going to go bar. What we might do is a value count. So I'll run this, or I could run a bar graph. I'm over time. I'm going to show you what this looks like, but if you need to go, there's the door. I'm going to do sns.countplot. Python generally knows a lot of what's going on. Data, status, and then y is equal to employment status. All right, I'll see you on Thursday.
So our timer, do you want to just answer? How do we answer each question?
Oh, for homework 1.1.
Like, do we download the PDF and answer with words, or?
Yeah, so I guess it's not posted on Gradescope yet, but you'll just upload the visual. So I think the first question is like who collected the data, like that kind of thing. So that'll just be like a text entry.
Okay.
And then for the other ones, it'll be an upload.
I think I just like lost access to it. I had it last year, but so basically I have this here, but it won't let me like type anything. It says like unlicensed product.
Oh yeah, so you may have to re-register.
Okay. I tried using the one through the school that's like this, but it wouldn't let me like open up. Like, so this is like through the internet, like browser. This is like through the school.
Yeah.
It wouldn't let me. I mean, I might just have to buy it. I don't really know.
You don't have to buy it.
I don't have to buy it. Okay.
So you can get access to Excel on your computer, like not through the browser, through the institutional access. So there'll be like a code, like a registry code. I don't have time to walk you through it right now, but if you can't figure it out on your own, you can drop by office hours and we can try to.
Okay. I'll try to figure it
get some
out. If
text.
not, I'll just go to the office hours.
Yeah, sounds good.
All right, thanks.
Hey.
I was wondering, the mini quizzes will start next week.
So not next week. It'll be the end of part 1. So once we get through all of the content in part 1. Yeah.
Yeah, so like how well read, like handwritten notes.
Yeah. So if it's on like an iPad, if it's feasible for you, I would have you print them off. If it's not feasible, we can talk about. Yeah, I could give you an exception.
Okay, thank you.
Hey,
I'm Lucas.
Lucas. Yeah. Wait, so we have 2 Lucases.
2 Lucases.
And a Luke. Yeah.
And Gradescope.
Yeah, Luke on board.
Yeah. Remember Gradescope?
can turn in my assignment.
Oh, yeah, yeah. Give me just 1 second. I'm going to turn off.